Hi guys, thanks for clicking on this video. In this video, I'm going to go through everything you need to pretty much know about momentum and how it tends to come up in the form of exam questions in AQA, OCR, EdXL, A-level physics, and pretty much all other exam boards as well, whether you're an international student or a student in the UK. So we'll start off by going through some of the key information. So this is how you'll see the equation in the equation sheet. P stands for momentum. If you're worried about the units, I'll show you a trick on how to find the units. M stands for mass and V stands for velocity. We'll talk about how this is different from speed in a little while too. I'm sure you know mass is measured in kilograms and velocity is measured in meters per second. In that case, momentum is the multiplication of kilograms and meters per second, meaning it's just kilograms meters per second for the unit. Moving on, it's asked, what's the conservation of momentum? Well, I would also include this. Just in some questions, I've seen this be a 2-mark question where the second mark is for mentioning in a closed system. But the total momentum before a collision is equal to the total momentum after a collision. Now let's have a go at using that in this next not multiple choice, but in this next exam style question. So I'm just going to make it a little bit smaller. And I'll show you how you're expected to use it. So it tells you a model truck A. Let's draw this out. So we have truck A, which has a mass of 1.2 kg. It says that it's traveling west with a speed of 0.9 meters per second. So you have to be very careful here because it mentions 2 different directions, and I'll talk about why that's important. It also tells you there's a second truck B traveling east towards A. So let's draw that to the left of it, A. So it's traveling towards A, this time with a speed of 0.35 meters per second. On top of that, we know that its mass is equal to 4 kg. So let's write that out. Okay. Although the speed is 0.35 here and 0.9 here, are those the velocities? No, they're not actually, because velocity is dependent on direction. So if velocity is positive in one direction, for example, if we take 0.35 to be positive to the right, then to the left, the velocity would be negative. So it'd be minus the magnitude of the velocity, which is the speed, 0.9 meters per second. Now, you might ask a question, well, what if I took positive 0.9 and minus 0.35? Actually makes no difference. They're both correct. The reason why is because whether you get a positive or negative answer, it's asked for the magnitude, which is like the size. So it doesn't matter whether your final answer is positive or negative. How do we now find the total momentum? So the total momentum is the momentum of truck B plus momentum of truck A. So momentum, we mentioned before, is mass times velocity. So let's write this out. The momentum of truck B is the mass of truck B multiplied by the velocity of truck B. So that's the mass of 4 multiplied by the velocity of 0.35. And then we add on to that the momentum of A. So again, the momentum of A is the mass of A multiplied by the velocity at A. The mass of A is 1.2 kg, and you multiply onto that the velocity of A, which we've established is minus 0.9. Now when you add those together, I'm just going to very quickly do that on my calculator. So we have 4 times 0.35, and then 1.2 times 0.9, minus 0.9 that is. And that gets you 8 over 25, or 0.32. Now, if you called the other V minus 0.35 and this one positive 0.9, you'd get minus 0.32 kilograms meters per second. But because it is just asking for the magnitude, we just take the size, which is just 0.32 kilograms meters per second. Now, in this next part of the question is where you use the conservation of momentum. What we found is the total momentum before the trucks collide. It tells you that the trucks collide and stick together, and it tells you to find the velocity after the collision. Well, let's write this out in words. We can say that the total momentum, I'm just going to write out as P to hurry things up, before the collision, which we've already found is 0.32 in the previous part of the question, is equal to the total momentum after the collision. And we can use that to form an expression. Because the total momentum after the collision is the mass after the collision, but because they stick together, that's very important. That means that it's a combined mass that we have to take when we do momentum equals mass times velocity, because they're stuck together. So you do 4 plus 1.2, that's equal to 5.2, but I'm just going to write the full working out, multiplied by the velocity that they move off with, the combined truck and car. So that's equal to 5.2 V, 0.32 that is. You can then divide both sides by 5.2, which I'm just going to very quickly do on the calculator again. And that's equal to, well, let's write this out actually. So your next step of working out would be V equals 0.32 divided by 5, and that's 0.062. 0.062 meters per second. That's your final answer here. Hopefully that makes sense on how you can use conservation of momentum in calculations. Moving on now, this is a very common exam question that I realize come up in exams. So that's why I wanted to go through it, and a lot of students struggle with it. Before we do, something that's very, very important actually. Whenever you multiply the two same types of quantities, like a vector times a vector, your answer will always be a scalar. Whereas whenever you multiply two quantities that are different types, like a scalar and a vector or a vector and a scalar, the answer will always be a vector. For example, if we look at force, which is mass times acceleration, so breaking down force, mass is a scalar, acceleration is a vector, and so the answer, which is force, is therefore a vector. If, however, we look at something like energy, for example, we know work done is equal to force multiplied by displacement. Force, we just established, is a vector. Displacement, we also know, is a vector. And so when you multiply these two together, you get work done, which is a form of energy, which is scalar. And actually, that's misunderstood a lot, the fact that energy is scalar. A lot of students think energy is a vector. Lastly, let's have a look at using this expression here. Before we do, there's something that I wanted to mention: impulse and momentum. Let's first establish which one is a scalar and which one is a vector. So impulse is equal to force multiplied by time. Force is a vector, time is a scalar, so that means that impulse itself is a vector. Breaking down momentum in a similar way, we get that it's mass times velocity. Again, mass is a scalar, velocity is a vector, so this multiplies to give a vector. Impulse and momentum are both vectors. To do this question, we're going to use the fact that impulse is equal to the change in momentum. Now that's equal to mass times the change in velocity, because a mass is always constant in an interaction. So if there is a change in momentum, it's caused by a change in velocity. If we divide both sides by t, we can get that the force is equal to mass times change in velocity over time. That's the change in momentum over time. So, or you can say the rate of change of momentum, and we can use that here. Now I'll tell you where a lot of students make a mistake, because from here it's easy to see that mass is 0.3, time is 0.05, time of impact, but what's the change in velocity? Do you remember before I said velocity is dependent on direction? Meaning if you take it as positive in one direction, like we're doing here, then we have to take it as negative in the opposite direction. In that case, the change in velocity is the change between 10 and minus 7. Now, it doesn't matter whether you take the change as positive or negative. Again, it will say in the question, find the magnitude. So between 10 and minus 7, the change is 17. So we can say times the change in velocity, which is 17, over 0.05. Let's now put that into a calculator. 0.3 times 17 over 0.05. And that's equal to 102. Now, because force is measured in newtons, we can just put newtons. I hope you guys can see here how everything in momentum sort of fits together like a puzzle. But yeah, went through two different exam questions, and these are the ones that come up most commonly in this new spec of A-level physics. Thanks for watching, and be sure to leave a like if the video helped. Thanks for watching. I hope this video helped. If you have any tutoring inquiries, be sure to visit my website www.excellineducation.co.uk. It's on the first link in the description too.